this is Calculus 12, Chapter 4.5, Part 2. We're going to be looking at differentials, and they're useful for approximating errors. This is closely related to linearization, and the definition is let y equals f of x be a differentiable function. The differential d of x is an independent variable, and the differential dy is f prime of x dx. Okay, this is confusing, so we'll look at it graphically. And how can we use this to estimate the change or the error? We're looking at the change in f. That's here to here. So if we have f of a, and we add dx, we have f of a plus dx. So the change is f of a plus dx minus f of a. So this is our change in f. If we use a linearization, this is the change in L. That is f prime of a times dx. Okay, so here we have the slope. This is dy dx. That equals f prime of x. And we can look at this as the change in y over the change in x. And that's approximately f prime of x. So the change in y is approximately f prime of x times the change in x. So it's not helpful to have dx in this picture. We actually want to have delta x. So delta f is approximately delta L. Okay, we can use differentials to estimate change. So let f of x be differentiable at x equals a, and the approximate change in value of f when x changes from a to a plus dx is df equals f prime of a dx. Okay, so it's helpful to memorize or use this chart as a reference. So the absolute change, that's what we just did. Normally, we would like to express this as a relative change or a percentage change. So it's handy to think of it as these expressions. Okay, let's look at some examples. Write a differential formula that states the given change in volume or surface area. Okay, so we have the surface area of a sphere, 4 pi r squared, when the radius changes from a to a plus dr. It's best to think of this as S of r equals 4 pi r squared. So we have ds dr equals 4 pi times 2r. So ds equals, this is 8 pi r dr. Okay, that's all we have to do. The change in ds is related to 8 pi r times the change in r. Next one, 38. Expanding a circle. The radius of the circle is increased from 2.00 to 2.0 meters. Estimate the resulting change in area. Estimate the percentage of the circle's original area. Okay, we start out with our formula, A of r, and the area of a circle is pi r squared. So dA dr equals pi times 2r. So dA equals 2 pi r dr. Now we just substitute our values in. We have this, and we have 0.02. So dA equals 2 pi 2.02. This is equal to 0.08 pi, and that's approximately 0.251. This is dA, so we're looking at meters squared. So the percentage error equals dA over our area at 2 meters times 100%. And now we just substitute 0.251 over 4 pi. We substitute 2 into here. We have 4 pi times 100. And that's going to be about 2%. So as you can see, the absolute change doesn't mean too much, but as a percentage, we can see that it's a small percentage. 40. The edge of a cube is measured as 10 centimeters with an error of 1%. The cube's volume is to be calculated from this measurement. Estimate the percentage error in the volume calculation. Okay, so we need to calculate ds. That's 10 times 1%. That's 10 times 0.01. So this is 0.1 centimeters. We should calculate the volume of the cube too. V of s equals s cubed. V of 10 equals 10 cubed equals 1,000 cubic centimeters. Now we can proceed with our calculations. dVds is 3s squared. dV equals 3s squared ds. And we have 3 times 10 squared times 0.1. And this gives us 30 centimeters cubed. So our percentage error, we have dV over V10 times 100%. Now we substitute our values. dV is 30. Our V is 1,000 times 100%. Okay, you don't need a calculator for this. We have 1, 2, 3 zeros in the denominator, 1, 2, 3 zeros in the numerator. That cancels out. We have 3%. And sometimes the harder problem is working backwards, and in this case, it is the harder problem. The height and radius of a right circular cylinder are equal. So the cylinder's volume is V equals pi h cubed. The volume is to be calculated with an error of no more than 1% of the true value. Find approximately the greatest error that can be tolerated in the measurement of h, expressed as a percentage of h. Okay, let's start off with our formula. dV, and we want V of h. We want the volume to be less than or equal to 1%. Let's set up our formula. VH equals pi h cubed. So dV dH equals 3 pi h squared, and dV equals 3 pi h squared dH. Substituting back into here, we have absolute value. Anytime you see variables that are the same, you can always substitute. And it's a good strategy in helping you solve. And we have VH, so we want to substitute that in. Pi h cubed times 100%. Let's fix that, put a percent there. It's less than or equal to 1%. Okay, we need to do some algebra on this. We need it to look like we want this to be a percentage of h. So we want dh over h times 100% less than or equal to some value. Okay, we have a dh and an h here. That's good. Let's cancel. We can cancel pi. We can cancel h squared. So we need to take the 3 outside. So 3 absolute value dh over h times 100% is less than 1%. So all we need to do is move the 3 over to the other side. dh over h times 100% is less than or equal to 1/3%. And that completes this lesson.